We're good to go? Couple of minutes. And I'm chairing this and I will keep time. So the first speaker we've got coming up this afternoon is Emily Corbett. She's a Beef Extension Officer from the Department of Agriculture and Fisheries in my home state of Queensland. So I'll throw it over to Emily to talk about legume-based production paddocks.
Howdy all. Quick question, raise your hand if you have ever been to the Northern Gulf or Cape York of FNQ. Awesome, that is my patch where I live and work. So I am here today to talk on behalf of my colleague Kendrick Cox, better known as Roo, who I'm pretty sure has been working in pasture research in FNQ since I've been in nappies. So I'm going to do my best to cover his work here today. So the beef and feed-based team have been doing some work in North Queensland to improve weaner and steer growth during the dry season. We have been using production paddock concept, using mostly deep-rooted perennial legumes like stylos and leekina, sometimes fertilised with phosphorus or sulphur to get the most out of the smaller areas on property trials. Clicker work. Sweet. So why do we do this? Grazing in our region is based on mostly native grasslands in uncleared woodlands, and these pastures hay off shortly after the wet season, which results in protein and energy deficits during the following 6 to 7 months, which is when we mostly need our high quality feed for our weaners. This occurs on both fertile and infertile soils, like those shown here. Deep-rooted legumes enable us to extend the growing season by providing the nitrogen required for fermenting stemmy grasses in the rumen and directly contributing to growth. One of the greatest challenges we face is the steady decline of land condition on many land types in our region. This has coincided with the spread of early flowering, low-yielding grasses like Indian couch. Along with careful management of stocking rates and spelling, the development of dry season pastures could be used to take pressure off grasslands by increasing weaner turnoff. So how do we do this? We began by screening a range of promising grasses and legumes on different land types across North Queensland. The plots were grazed in the dry season and herbage yield and quality was measured along with acceptance to cattle and the capacity to seed. After 4 or 5 years of testing, the higher performing lines were put in larger trials like these ones that you can see here. On the left, you can see the fertile basalt site near Mount Surprise, and on the right, the relatively infertile red earth site near Charters Towers, which is Spyglass, if anyone's aware of that. Each plot consists of a unique combination of a grass and legume with up to 63 combinations. There were 3 replicates at each site. Fertilisers were applied, but only at sowing. Only sulphur was applied to the red basalt, but phosphorus and sulphur were both required on the red earths. The plots were allowed to grow over the wet season and pasture composition, and the yield were measured before grazing in the dry season. We also tested production paddocks at paddock scale to measure animal performance. Here is a replicated experiment on red earth soils where redlands and wonder graze leekina were grazed using 4 cohorts of cattle over 4 years. Legume leaf was produced all year but slowed when it became a bit colder in the July. This intensive production system was compared with fertilised buffel and stylo pastures in the neighbouring paddock. So how did it go? This is my final slide. High herbage yields were achieved 2 to 3 times what we would normally produce on these land types in A condition. Importantly, leaf quality was high in the dry season when grasses have hayed off and are of poor value. Excellent animal growth rates were achieved in the live weight gain study, with about 0.6 kilograms achieved per weaner steer, average over the year at high stocking rates. Lakina could handle stocking rates twice that of the Buffel and Stylo pasture. When we ran some economic analysis, we found that the system to be highly profitable, particularly on fertile soils where phosphorus fertiliser was not needed and pasture yields were high. From here, we plan to set up demonstrations and work one-on-one with our local producers to adopt legume pastures. I'd like to thank my team and recognise our co-funding from the MLA for the work. Thanks.
Thanks, Emily. We've got time for a question, quick question.
Can hit me with the questions, but I don't necessarily know the detail, but I'll try. I was like, oh gosh.
Hi, it's Rob Pearce from Western Queensland. Sorry, I missed the actual start of your talk, I'm sorry, but is there any difference in the productivity from Lakina from the sterile variety to the seeded variety? Do you know?
Ooh, I'm not sure. The trial site that we were using was Wonder Greys and Redlands, and there wasn't too much difference. It wasn't a huge difference, and that was just mainly those varieties are different to be psyllid resistant. But I can find out that data though, but I'm not sure. I can't answer that question, I'm sorry.
Awesome. Okay.
Thank you.
Thanks, Emily. Okay, next speaker, another 5-minute quick one from Jeff Moore, Department of Primary Industries and Regional Development. Just going to talk to us about the risk of agricultural plants becoming environmental weeds in the Northern Rangeland.
Thank you for the opportunity. I've got 5 minutes, so I'll get into it. So, agriculture in Australia is based on non-exotic or non-indigenous plants, whether it's cropping, horticulture, improved pastures. But on the other hand, there's been many cases, and there's key papers like Lonzo 1994, where plants introduced for agriculture become environmental weeds or serious environmental weeds. Think of gamma grass in the NT, for example. So I'll start with a question for you to get you thinking. So here we've got 4 plants. Got A, sunflower, B, Rhodes grass, C, Lucina, and D, cotton. And my question to you is, which of these agricultural plants can be a weed? So think about it, okay? And I'm not going to get over your time, so I'm just going to give you the answer. The answer is all of them, because the common definition of weed is simply a plant in the wrong place. So, but now I'm going to pose a different question, which is subtle, but it's different. So, which of these agricultural plants can become an environmental weed? And a simple definition of environmental weed is a plant that adversely affects the natural vegetation. So think of that, and I'm going to give you the answer for that later. It's a bit more nuanced, so we need a bit more subtlety. We need to look into this in more detail. So that's why we're, with my co-authors, we released a methodology last year for looking at this assessment system. And it's based on, it's in the bottom right corner for you. There's the FFI, Future Farm Industry, CRC, developed a post-border weed risk assessment methodology. So we've based it on that, but adapted it for the rangelands. It's got 3 sections. There's a whole series of questions on invasiveness, a whole series of questions on impacts, and then it's looking at the potential distribution based on soils and climate. But we did add a filter, because there are a lot of species. Well, the full documentation, just to get to the bottom, takes about 10 to 15 pages. So it's a lot of work. It takes maybe a week to do a species, and we're looking at a large number of species. So we did add a filter. So basically takes out and that the documentation for the filter species is only 2 pages, so that cut to the chase. So, and also we did some nice high quality potential distribution maps. We used FAO EcoCrop database climate data and matched that with the soils database from the Deep Herd, and then we got Rachel Whitsett from Charles Sturt University to sandwich them together in a GIS system. And then we've reassessed 100 species, which if you click on this QR code, it takes it to our website. And if you scroll down, there's a big table. And then with all the species, on the species name, it's underlined. If you click on that, it takes you to the documented evidence. So it's a very transparent system. So, yeah. And keep moving. Okay, so for the Kimberley, sunflower in our system, we've gone through that. It's negligible to low environmental weed risk. Rhodes grass above 550 millimetres comes out as a high, Leucaena very high, and cotton is negligible to low. So in a nutshell, we've developed a methodology which is published it. We've developed for WA, but it's relevant across the whole of Northern Australia. We've assessed or reassessed 100 species using that methodology, and the results are on our website. So thank you.
Spectacular. Any questions for Jeff?
Have you assessed buffel grass?
Yeah, so buffel grass is obviously the most contentious species in the agricultural space with WA anyway, probably across the whole of Northern Australia, are Leucaena and buffel grass, because on one hand they've got high grazing potential, on the other hand in certain situations they're serious environmental weeds. They both come out as very high, so which is the scale is negligible to low, medium, high, very high. So they come out of the, yeah. But, and the documented thing. Okay, sorry.
Yeah, so in your slide you said Rhodes grass comes out as a high weed risk assessment.
Yes.
But it's been approved, so only very high risk assessment is knocked out? Is that how it works?
Yeah, so just to go back a tick, to fill people in, in WA to grow any non-Indigenous or exotic plants on pastoral leases, you need a diversification permit, and you're unlikely to get a permit for a species that's assessed as very high. But yeah, but what we've also done, which is, we didn't have time to talk, we've brought in things like biosecurity plans and also monitoring of irrigation, regular monitoring systems. So we've, on one hand, we've increased the number of options for pastures. On the other hand, we've put in safety mechanisms as well. Yeah, if I hopefully answer your question. Thank you very much.
Excellent. And on to rubber vine. So our next speaker is Curly Yates. He's from the Department of Prime Industries and Regional Development. He's a long-term Kimberley resident, only recently joining the biosecurity field in a professional basis, despite being passionate about the environment and the Kimberley for a long time. So Curly's going to talk about rubber vine eradication in the East Kimberley, collaboration to fight a common enemy.
Good afternoon, everyone. My name's Curly, and I'd like to talk to you this afternoon about our eradication plan for the rubber vine in the East Kimberley. So, which button? That one? Oop. Yep. Okay. So, rubber vine, you may or may not know about. I thought that my life revolves around rubber vine, so I thought everyone must know about rubber vine, but not everyone does. So this is rubber vine, and this is what it can do to your trees in your pasture. So rubber vine was first found at Lizardell Station at the bottom end of Lake Argyle in 2009. It was soon thereafter also found at the Argyle Diamond Mine and the Bow River Mine, which are nearby. Rubber vine primarily grows on riparian, in the riparian zone, but it will also grow out in the pastures where there's sufficient soil and moisture. The soil and moisture that it requires is anywhere between 400 and 1400 mils of rain, which basically puts it all the way across the top end rangelands. I'd just like to show you a quick video now of rubber vine, a patch that we found.
Is that the biggest bloody kangaroo you've ever seen?
There wasn't supposed to be sound with this. So excuse any expletives that might come out, because it's like, yeah, pretty scary set of rubber vine. You can see that there is pasture below the rubber vine there at the moment, but that's just getting choked out. So what you need to grow your cattle is the pasture, and rubber vine's going to just take care of it. More identification of rubber vine. So rubber vine has a very showy white flower, and it has these seed pods. Those seed pods, I think there was 237 pods, came off one single plant. Each pod can hold up to 800 seeds. And they have a very high germination rate when they mature. Anyway, so what are we going to do about it? We need to plan what we're going to do. So what we do is we actually perform each year aerial survey. By that we do gridding 2 observers in a helicopter, and we travel transects. Now everyone goes, oh, you get to fly around in a helicopter. That's so good. Yeah, but when you've done 7 days of 30 metres above the ground, just looking out, it's no fun. It really is not. So we do transects over the likely areas. This is where we did in 2022, which was around about 27,000 hectares. Loads of fun. From that, we then identify we do that towards the end of the wet season, and we identify and mark any. Oh, we've got a pointer, I think. Oh! Yeah, I fell for it too. We've got the points. We mark with a GPS where we see the rubber vine flowers, and then we put that into a database and we go back and do them. In addition to that, we also mark where we have previously found rubber vine. From that, we then developed a grid system, because most rubber vine seeds fall within 10 metres of the mother plant. So we do a 50 metre grid around each plant, but where it's a flowering plant that we haven't seen before, we make that 150 metres square, just to give ourselves a bit of a buffer zone, so that we can make sure we're catching it all. The historical data that we use, rubber vine seed longevity is around about 2 years. So for every plant that we find, we search that area for 2 years, and for every flowering plant or mature plant that we find, we give it 5 years. 2 years for the seed longevity, and a couple of years for if it's growing in a pasture. First year it might only be this big, pasture's this tall, you're not going to see it. So we give it a couple of years to make sure it gets up, and then we can kill the little sod. From there, we go out. Which is the laser pointer?
Right at the top.
The top one? Rightio. So we've developed our gridding system, okay, and we get some rangers, DBCA, Department of Biosecurity and Conservation, or Parks and Wildlife, whatever you want to call them, and Deep Herd, and local contractors that are suitably qualified to come out, and we get to walk up and down and look for rubber vine plants. This is really good fun too. I love it. So once we find a plant, we then go through and in those areas where it is most of our stuff is reasonably sparse rubber vine. We're very lucky, we've got it nearly under control. So we use a cut stump method, or if they're only very young seedlings, we actually do some manual pulling. Unfortunately, every now and then we do come across thick infestations like we found that one this year. So what we do in those areas is we do foliar spray with herbicides, and then we come back once it's safe environmentally, you know, so we're not going to get a wildfire, and we burn it, because you can't get through all of that stuff you saw in that video. You're not going to be able to get through that. So we come back, we burn it, that then opens up the country, kills most of the rubber vine, and then we can come back next year and do our manual spraying, either basil bark, cut, stump, however we like to go. Right. Of course, with any good program, you need to review your work. So no one sees everything. No one sees everything. So what we do, where we've got the available resources, we go through and do a second pass of those areas that we've gone, there was a fair bit there, we'd better go and have another look. Do a second pass, that's good. The gridding system that we use was developed back in 2014 by Dick Passfield and Vernon Sadler, and we found that to be very good. Normally it works, but works very well. So that's an update that we made a fair while ago. And what we're going to now is machine learning, artificial intelligence, remote sensing, whatever you want to call it. We're in the second year. We've done 1 year of a trial where we actually use drones or cameras to actually spot the rubber vine, and we're working on trying to detect it by foliar and the whips. If you're familiar with rubber vine, it has a very large distinctive whip. Right, so I want to say thank you to the people who are involved in this, the Kimberley Rangelands Biosecurity Association, Department of Biosecurity and Conservation, and the funders, or major funders, NRM, and everyone who is prepared to walk out there well, we've still got a couple of months to go, so if you want to come and walk through the bush in October, November, just give me a call. And you probably want to know how we're going with it. So this is where we've got to. We've got 62% eradication areas, and there's we're down to about 46 hectares at the moment, and hopefully we'll get that better. Thank you very much.
Fantastic, thank you. Any questions? A bit of time. Yeah.
No, I don't want questions.
Thanks very much, Curly. It's a great presentation. Having had some experience with rubber vine myself in the Charters Towers area, 2 questions. Does the rubber vine rust work over here, or insufficient wet season rainfall? Or?
We haven't seen it, and it might be a little bit dry for it, we reckon.
Has it been introduced?
I've only been on the program 3 years, and it hasn't been introduced yet, but it's something that we can look at, yeah.
Did a great job around Charters Towers, the rust.
Yep.
The second question is, what we found on the towers, a lot of control work was done with fire and chemical control work.
Yep.
The grazing land management that allowed the weed to come in the first place didn't change. So what happened was the rubber vine got knocked out in some areas and bellyache bushes come in behind it. Any similar observations here?
Yeah. That fire that I showed you there, I don't actually have the will it go backwards for me, or I'm past it? No. So that fire that I showed you, that was an area probably the size of this room that was completely impenetrable. We sprayed it, we burnt it, we went back the next year at the aerial survey, and that was a lush piece of pasture. We went back the next year, and it was a lush area of bellyache bush. Yeah. So we've replaced one weed with another, but yeah, unfortunately the way that the government declares things for WA, bellyache bush is not a priority for us at this stage. We'll try and work on that one. Yeah, look, we've also got some rubber vine over here in Fitzroy, and we were recently working in there in the Negura Burr, and the people who'd worked in both said, oh yeah, much rather Negura Burr than bellyache bush. So yeah, bellyache, unfortunately.
So it's a very recent discovery. It's a very recent discovery, 2009.
Yep.
And all those sites sort of stem from the Bow River downstream.
Yep.
Have they ever been able to trace where it came from?
So it was originally found at the Lizardell homestead. Sorry, when I said Lizardell, I meant the Lizardell homestead. It was found as a garden plant. Like so many of our environmental weeds, it started its life as, oh, that's pretty, isn't it? Let's have some in the garden. And yeah, Parkinsonia, another great one. Yeah, and bellyache bush. Yeah, was introduced as a bloody garden plant. Sorry.
Excellent.
Okay.
Well, join me in thanking Kelly.
Thank you.
Excellent. Okay, from rubber vine onto camels now. Our next speaker, Natalie Pearce, is a Senior Project Officer from Desert Channels, Queensland. She's been involved in the survey of floral biodiversity and ground cover through formal assessments and the documenting of outcomes and recommendations through reports to internal and external clients. But here today she's going to talk about camels, weapons against weeds or liability for landholders. Over to you.
Thank you for the introduction. So this is a study that's been funded by the Desert Channels Foundation and has been running for the last 3 years to explore camels as a potential management tool for reducing the spread of prickly acacia in the Mitchell Grass Downs bioregion. So prickly acacia is a weed of national significance, which covers about 21 million hectares in variable densities across the Desert Channels region. For those of you that aren't aware, the Desert Channels region encompasses the Queensland section of the Lake Eyre Basin, which is about a third of the state of Queensland. So our trial site was located about 50 kilometres south of Hughenden and hosts a small herd of about 18 educated camels in an 82 hectare paddock, which contains 23,162 mature prickly acacia trees, which we know thanks to the hard work of a particularly dedicated work experience student who counted them for us. Yes. So prior to the commencement of this study, it's been sort of commonly acknowledged in the region that camels will preferentially graze the prickly acacia flowers and seed pods. However, many of the landholders in the region have avoided adopting them as a potential management tool because they don't want to have to reduce the stocking rates of cattle in order to also run camels. So that's been a key driver for this particular study to determine whether there is any potential for camels and cattle to be grazed concurrently without having to drastically reduce stocking rates. So we've tried to address a few key questions as part of this, which have been, will the camels graze all densities of the prickly acacia? What impacts will the camels have on the prickly acacia plants? Whether the camels will have any impact on land condition, and whether the camels will have any impact on floral biodiversity. So we've undertaken an extensive monitoring within our trial site, both during the wet and dry seasons. And monitoring points have been in place across our trial area, but also at a control site outside the fenced area. So one of the main things that we've done has been regular drone monitoring across the site, and this has allowed us to generate high-resolution orthomosaic imagery, which can be analysed to measure the densities of prickly acacia, along with the changes in canopy cover in areas where the camels have been present compared to the control site, and also changes in the extent of perennial grass cover within the trial area. We've also undertaken and field monitoring assessments to determine changes in floral biodiversity, and also the physical impacts on the prickly acacia plants. We've also fitted each of the camels in our area with GPS ear tags in order to measure the grazing distribution throughout the paddock and identify the areas in which they're spending the most time. And on all field assessment occasions, whenever staff were on site, we've also made sure to undertake assessments of camel health and condition. So we've generated a map of the prickly acacia densities across the site, and I'm hoping